Hello everyone. In this video, we'll learn about another technique to solve a system of linear equations using matrices. This method is known as the Gauss-Jordan elimination. And at the end, when you start reducing your augmented matrix for any system, you will end up with the row-reduced echelon form of that augmented matrix. A typical question in the exam or homework assignments will look like this. You will be given a bunch of equations and you'll be asked to simplify the system using Gauss-Jordan elimination. Now, we will take a basic example in today's video. I just want to show the process and how the resultant matrix, what the resultant matrix will look like. There are several variations in the final result. Sometimes we have no solution, infinitely many solution, or a unique solution. We will discuss those cases in the next video. So let's pick this question from your textbook and we'll recall the strategy for Gauss-Jordan method first. So the steps are same until for the Gaussian elimination. But in this case, once you have a pivot entry, once you have a 1 in your pivot entry, you need to make everything below as well as above 0. So let's go through this question step by step. We'll follow this step. This is the most efficient algorithm that we'll be using throughout chapter 1. Now, I first construct the augmented matrix, as you can see here. And this is the coefficients. This is the right-hand side, the constants. Now, I begin with the first entry, the upper left entry of my matrix. This is a non-zero entry, but this is not 1. So what do I need to do to make this entry a 1? I need to multiply row 1 by a negative 1 by 4. And that gives me the desired outcome. Now, I'm only making a change in row 1. So I'm going to leave everything as it is. So these rows do not change. Rows do not change. Now, so far, you are aware of what row operations are valid. I'll remind you again. We can only swap two rows, multiply a row by a non-zero scalar, add a non-zero scalar of any row to another row, okay? Now, in this question, I'm trying to do something more advanced. You see, I have a 1 in my pivot entry here. I need to make everything below it a 0, right? As long as I'm using the same row, and I'm using the same row to operate on other rows, I can combine my row operations in a single step and get this done quickly. Now, I do not recommend this if you are new to this method. I would say you can use as many steps as you want. I'm combining all my steps. I'm making 3, -2, -2, all of them 0 in one step. Now, you have to be very focused and very careful when you do this in one step. Requires, let me say this here, requires focus, okay? If you wanna try this at home. So let's pick this matrix here. I'm gonna be changing. I wanna make everything below this pivot 1 a 0. So I'm gonna make a change in R2. R2 will, so that's why we make the first entry 1, right? So that everything is easy to change. I just need to add a negative multiple of R1 to R2 to get that entry to be 0. I need to add a positive multiple of R1 to R3 and same for R4. Now, the whole row will change. This whole row will change. You will add a -3 times 1 by 4 to this entry. So every entry in each row changes. Now, do this calculation on your own and verify if you have the same answer. Okay. Now, you see, my first column is sorted. I have 1 here, zeros below it. There's nothing above it. So I can move on to the next pivot entry, which is the second row and second column, this guy. So look, as long as I'm changing row 2, I cannot combine operations here because I'm making a change in row 2. Cannot combine operations here as row 2 will change, right? So I cannot just make everything above and below it 0 because I need to first make this 5 by 4 a 1. How do I make this 5 by 4 a 1? I just multiply by its reciprocal. Multiply by 4 by 5, and there we go. So now this pivot entry is done. I need to make everything above and below it a 0. Again, I'm combining all my row operations in one step. Not required, but you can do this to save time. You're welcome to do this for written homeworks and even during exams. You're welcome to do this. All I would recommend is be focused. Now, so I'm changing all the entries above and below this second row, second column 1. And you know now what is the drill. I need to add a negative of 1 by 4 to this guy, to row 1, a positive of 7 by 2 to this guy, and a negative of 1 by 2. And there you go. All my row operations are listed here. And once I apply that, once you do the math, you know that each entry, even the augmented part, will change. Also changes, right? Because the augmented part gives you the final answer. So you need to change, you need to do your math on the augmented part as well. Otherwise, the final answer won't change. Now, I have a 1 in the upper left corner, zeros below it. So I'm good there. I have a 1 in the second row, second column, zeros below and above. So I'm good there. Now I need to move on to the third pivot entry, which is the row 3, column 3. We keep on going until there are no more rows left. So I have a third pivot entry here. I need to make this guy a 1 and everything below and above it 0. But because I want to make this a 1 first, we need to operate on that row alone. So how do I make this guy a 1? I multiply row 3 by negative 5 over 12. And there you go. Simple math. Now, once I have a 1 in my desired location, I can use row 3 to make everything below and above it 0. So I'm focused on this column now, and I'm making everything below and above this 1 a 0. So row 1 needs to be operated on, row 2 needs an operation, and row 4 needs a row operation. And the numbers here are exactly the opposite sign of what we need. So I have a negative 2 by 5 in row 1 above the pivot entry. So I need to add a positive 2 by 5 of R3. So how does it work? You see a 1 in this position, right? I need to multiply this 1 by something so that this negative 2 by 5 becomes 0. So what do? I add a positive 2 by 5 to it, right? Similarly, I need to make this 11 by 5 a 0, and I need to use this 1 above. So what do? I subtract a negative 11 by 5, right? So take your time, take a look, see how the operations are going on. This is a difficult question. You probably won't see it in a midterm exam, but it's good practice. So once I apply all the row operations, I do all the math, I get my desired column. So I have a 1 here, zeros below it. I have a 1 in the pivot entry, zeros above and below. I have 1 in the pivot entry, zeros above and below. I move on to the last pivot entry, which is this guy. This is a 5, not a 1. So I need to make this a 1, straightforward. I divide everything by a 5. So I operate on row 4. This is my row 1, row 2, row 3, row 4. I operate on row 4 and I divide everything by a 5. There you go. The matrix looks very close to the reduced row echelon form now. So I have a 1 here, but I need to make these two guys 0. So very straightforward math. I have a 1 here, so I need to subtract row 4, right? So from R1, I'm subtracting row 4. I have a negative 1 here, so I need to add row 4. So you will look at the numbers right above that entry in that particular column, but you'll write your row operations using the entire row. But the row operations that you'll perform are determined using the numbers in that particular column. So I'm subtracting row 4 from row 1. So each entry will get subtracted. I'm adding row 4 to row 2. So we add each entry, and there we go. Now I have ones in each pivot entry, zeros above and below. So this is my reduced row echelon form using Gauss-Jordan elimination method. Now, if I rewrite this reduced row echelon form as a system of linear equations, you see, we don't need to do any math here. We don't need to do any back substitution or any other more algebra to get our final answer. We're done. X1 is negative 16 by 5. X2 is 83 by 15. X3 equals negative 11 by 3. X4 equals 38 over 15. And we get a unique solution for this particular system of linear equations. There will be variations. There will be different types of solutions. Even after using Gauss-Jordan, we will discuss those type of problems in the next video.